Welcome to the TCG's Data Security Using TCG Self-Encrypting Drive Technology webcast. On this webcast, we have Tom Coughlin, Dr. Michael Willett, and Hussein, Syed, who will be talking about how to deploy self-encrypting drives, when to use them, and the realities of SEDs today. This webcast is being streamed online through BrightTalk. If you are having difficulty with sound, please make sure your sound on your PC is on. During the webcast, if you have any questions for our presenters, please click on Ask a Question button and type your question. We'll be presenting and answering these at the end of the webcast. Today's webcast is being led by Tom Coughlin, founder of Coughlin Associates, Dr. Michael Willett, storage security strategist at Samsung, and Hussein Syed, director of IT at Barnabas Health. I am Brian Berger, chief marketing officer at Wave Systems Corp. And a TCG board of directors director. Let's begin with Tom Coughlin.
Thank you very much, Brian. So I'm going to get things started off by looking at the current state of self-encrypting drive market, and the source materials for this are a report that I did on the projections and analysis of the self-encrypting drive market, as well as a white paper from the Trusted Computing Group who is putting on this webinar. Let's talk first about some market drivers for self-encrypted drives, otherwise known as SEDs. First of all, there is an increasing worldwide financial and legal consequences for data loss and data breaches. There are many laws in many countries that place great responsibility, which could have financial burdens and could even end up in jail time for people that do not meet those requirements. However, safe harbor laws in most of the United States and in the European Union do cover the case of loss of devices which have secured and encrypted data on them. In other words, it's felt that in that case, the data is adequately protected and cannot be accessed by somebody who gets a hold of a device that has information which they should not have access to. The Trusted Computing Group standards for notebook or portable computers, called Opal, and the enterprise storage and for enterprise storage devices using FIPS compliant AES 128 and 256-bit encryption are very good methods for providing this secure and encrypted data. These devices use hardware encryption, and doing encryption through dedicated hardware results in much lower overhead for encryption and decryption in the case of these self-encrypted drives than is the case for software encryption. Self-encrypted drives allow faster crypto erase, where you sanitize a drive by erasing the internal encryption key, therefore making the data crypttext, which cannot easily or perhaps cannot at all be recovered. And this is very useful for drive replacement, where a drive is being repaired, where it is being decommissioned, repurposed, or in the case of end of life, to make sure that data that's on those drives, whether it be in a consumer or in an enterprise application, does not fall into the wrong hands. Most major storage device companies today provide self-encrypted drives meeting the Trusted Computing Group standards. These include Seagate, Western Digital, HCST, which is now part of Western Digital, and Toshiba, who offer portable and/or enterprise Trusted Computing Group encrypted hard disk drives. Micron and Samsung provide Trusted Computing Group Opal compliant solid-state drives. And there are special advantages for Trusted Computing Group encrypted solid-state drives. The particular one is the best way of erasing data on a solid-state drive, of doing a sanitization of a solid-state flash-based device, may in fact be this crypto erase process. And therefore, it has a special significance in the case of repurposing, reusing, etc., protecting the data on solid-state drives. The overhead penalty in the case for software versus self-encryption in solid-state drives also may be more significant than is the case for hard disk drives, making this a very strong case for the use of Trusted Computing Group in hardware encryption in a solid-state drive configuration. We're now going to go into a little bit of information related to projections for the take-up of a self-encrypted drive capability. That is the basic ability built into either a solid-state drive or a hard disk drive that would allow it to be able to do encryption. Now, this is separated from the actual implementation of that encryption capability, but it is driven by the growth in the hardware being built into devices that would allow encryption to be used. And in the case of hard disk drives, as shown on this chart here, we project that by 2017, all hard disk drives will be self-encrypted drive capable. That means they can do internal encryption. With encryption integration into the controller as a reference point, over 25% of self-encrypted hard disk drives are self-encryption enabled in 2011. Now let's look at the case of projections for solid-state drives. We can show here for solid-state drives with this self-encrypted drive capability, we project that by 2013, 80% of solid-state drives will be the self-encrypted drive capable. And by 2016, we think the penetration will be near 100%, again driven by the unique value of these encryption capabilities for sanitization and other purposes with the solid-state drives. Now, in both its hard disk drives and in the solid-state drive, self-encrypted drive projection, you can see that we're, for the capability projections, that we have a high, median, and low estimate based upon projections of penetration and unit growth made at the time the report was done. So with that, that is my presentation for right now. I'll be available later for questions. I'm going to turn this over to Dr. Michael Willett, who is a storage security strategist, currently doing consulting work with Samsung, but he is also has a past with Seagate Technology and is a longtime proponent and activist in the Trusted Computing Group. So with that, Michael, up to you.
Tom, thanks a lot, and thank you for the promising and positive projection or forecast, if you will, of the future of self-encrypting drives. Well, all of us in the business knew it would be going in that direction, and we're just glad to see the projections for that. What I'm going to do today is describe both the business requirement for encryption and, in particular, self-encrypting drives, and also take a brief deep dive, if you will, into the technology of self-encrypting drives. First, let's look at the need for encryption. On a worldwide basis, we're generating just exabytes of data. Processed, stored, transferred data, and most of that data in fact, all data that you generate and process spends most of its useful life in storage. There are transient moments when data is transferred from one point to another, but if you look at the overall life cycle of data, it spends most of its life in storage. And this storage is very mobile. We certainly appreciate that laptops and cell phones and those devices are very mobile, and that makes the data itself very mobile, but also the data is in a data center. There was an estimate at one time that 50,000 drives leave and enter a data center every day. So there's a lot of mobility in the data center itself, not just the mobile drives. And in these drives that are leaving and entering the data center, for example, IBM estimates that of those that were returned for warranty work, that is, we thought they were broken, 90% of those are still readable. So why secure data? Well, there's a lot of sensitive and confidential information contained in the data that we're processing, the data we're creating and processing, and it's growing exponentially. Worldwide, there are a number of global regulations, probably dozens of global regulations, that specify protection measures for stored data or for data in general, in particular stored data. I've listed here the payment card industry, the healthcare industry, the banking industry, and others have stringent regulations protecting data because of the nature of the data, the sensitivity and the personal nature of data. The states, 46-plus states in the United States, and national and international legislation called breach notification requires that if you lose or misplace or mishandle personal or confidential data, you've got to notify the public. There is an exception, however, if you can audibly prove that you had encrypted that information before losing or misplacing it, then in that sense it's not really readable, it's not really available. you can escape to what's called an encryption safe harbor. That is, you don't have to breach notify. That can save you a tremendous amount of embarrassment, both financial and reputational. There are, as I say, increasing consequences of not complying with breach notification laws. The Ponemon Institute, on an annual basis, estimates the average incident cost of having to do a breach notification. In 2011, that estimate was $5.5 million per incident. So it can be very costly if you have to breach notify. The Privacy Rights Clearinghouse maintains a database, by the way, of breaches that occur on a daily basis, and there's some untold zillions of records that have been lost or mishandled as of February of this year. You can, I'll have reference later to that database. It's very illuminating to see the ways and means of losing sensitive data. As I mentioned, we're generating exabytes of data. That number is growing exponentially on a worldwide basis, and a significant portion of that data contains sensitive or confidential information. In 2008, for example, the Ponemon figure was $6.5 million per incident. I mentioned 2011, the figure was $5.5 million, but very significant cost to having to deal with doing a breach notification. And there, as I say, there are dozens of legislative actions worldwide that put stringent requirements on the protection of such data, and also stringent penalties, if you will, if you don't comply with those protections. In fact, if a company has to do a breach notification, and you see these in the newspaper all the time, it's very embarrassing, it can have very severe legal and financial and reputation impacts on a corporation. In fact, some corporations have actually gone out of business because of the loss of their reputation, loss of customers, and so on, due to having to notify the public that they lost sensitive information. The scenario we're dealing with here, by the way, with encryption, the threat scenario that I'm dealing with in stored data, is when stored data leaves the owner's control. Now, that can happen a number of ways. There are exception conditions, like data being lost or stolen. Those are exceptions. We hope never happen, but they often do. There are also normal business processes that we do on a daily basis that cause us to lose control of the data, such as repurposing a drive, sending a drive out for repair or warranty work, end of life of a drive. All these are normal business processes that, however, cause us to lose control of the data. And I mentioned that the number one reason for encryption, and especially with dealing with stored data, where data spends most of its useful life, are the business or compliance requirements of breach notification. If you can prove that it was encrypted when you lost it, you didn't really lose it. So you don't have to breach notify and therefore save the cost and reputation of having lost data. I mentioned before that not only the laptops, but data center drives are very mobile. And I should point out we're talking about not just hard drives, the rotating media drives, but also solid-state drives, which are growing in prominence in both the laptop market and in the data center market. Exposure of data is very expensive. As indicated, the Ponemon numbers don't seem to be going down very much in terms of average cost of an incident. And again, I'm dealing with not only the exception conditions, but also normal business process conditions for how I lose control of stored data. The Trusted Computing Group has, through its storage work group, has developed a number of storage specifications. The industry got together on a cross-industry basis, the best and brightest of the technical folk from various elements of the storage industry have been working for a number of years on several specifications, several standards, if you will. There's a core specification, what's called trusted storage. And then there are various subsets, what are called security subsystem classes of that core spec that deal with particular environments. For example, as Tom indicated, the Opal spec is for self-encrypting drives in the laptop. The enterprise spec is for self-encrypting drives in the data center. I mean, here you can think SCSI or SAS-based drives. With Opal, you can think SATA-based drives. And there was even a special subsystem class developed for optical drives. So we have the core spec, and then any group that gets together that's interested in a particular environment can subset that standard down to a subset specific to a particular environment. I should also indicate I'm talking not only about rotating media drives and storage drives, as I've indicated, but also the laptop drives, and the data center drives. So it spans both dimensions, all of the standardized interfaces, if you will, for storage, as well as all the environments. There are a number of studies that document the comparison of hardware-based self-encryption to what is the standard, because, by the way, we had no other solution, that is using software-based encryption or indirect encryption, that is encryption operating outside the storage environment. There are a number of comparisons, and in every case, the hardware-based self-encryption wins out. Just to mention a few, transparency. The self-encrypting drive comes from the factory encrypting. It's always encrypting. It's born encrypting. The encryption key itself was generated in the factory by onboard random number generation process that's never externalized. So you, as I point out there on ease of management, you don't manage the encryption key. Lifecycle cost, the cost of the self-encryption function, which is built in hardware, in this generation of drives, is built directly into the drive electronics, into the controller of the drive, is prorated across that initial cost. And in fact, in this generation of drives, you're seeing very low incremental cost, and in many cases, no additional cost for having self-encryption. The disposal or repurposing cost is zero, in fact, because I can use the crypto erase function that Tom described, where I simply ask the drive to erase and replace the onboard encryption key and generate a new encryption key, and thereby making all the old encrypted data unreadable. There's no need for re-encryption with a software encryption, as there is with software encryption, rather. When you change the keys, you have to re-encrypt, but with a self-encrypting drive, you're not changing the encryption key, no need to re-encrypt. Performance, the self-encryption function is built in hardware directly in the drive electronics. There's no impact on no measurable impact on the performance of the drive itself. The important element here is standardization of the interface. The whole drive industry is building to this common specification described by the Trusted Computing Group, and that allows these drives to be managed, if you will, from a standard platform. That is, you'll see a number of software vendors in the industry developing management products for managing self-encrypting drives, and they are all building to the same interface. There's no interference with upstream processes. To you, the drive looks like a normal drive. What's written to the drive it goes in as plain text, comes out as plain text, because the encrypting function is right down in the drive electronics before the bits are placed on the medium. There is one issue related to self-encryption, and that is you've got to buy new hardware. But yet, this technology, if you will, is very mature. The specs have been out for 4 years or more. The drive industry has been building to the specifications. We're on our second and third generation self-encrypting drives, very mature, very stable, and so both small and large customers are finding they can replace their normal storage devices with self-encrypting storage devices as part of the normal replacement cycle. It just fits right in. Let's miniaturize ourselves and take a deep dive into the electronics, if you will, of a self-encrypting drive. I'm showing here the Opal use case for laptops, if you will, but this applies both to solid-state drives and to rotating media drives. There are two classes of keys described in the self-encrypting specification. There are a set of authentication keys. These keys are externalized and managed by the user and are used to lock the drive and unlock the drive. And then there are these embedded data encryption keys that are generated by the drive on board and never externalized. When I take possession of the drive, I will personalize the authentication keys. So from that moment on, then, the drive can recognize the authentication keys when presented. So in the morning when I turn on my laptop, before the operating system is initiated, the drive itself will ask me for the authentication key. So I have a pre-boot authentication process even before anything else happens with the drive, and the drive directly is asking me for an automated process for the authentication key. The authentication key is presented. It's compared to a hashed value of the authentication key that's stored on the drive. The drive never stores the authentication key itself, only the hashed value. If that match occurs and it's correct, then I presented the correct authentication key, as you see. Then that key is used to decrypt the encrypting key. This isn't getting too complicated. The encrypting key itself, when I personalized the drive, was then encrypted with the authentication key. So from that moment on, I don't even store the encrypting key in the clear on the drive, only its encrypted value. So the encrypting key is decrypted with the authentication key, and the drive is off and running as an encrypting drive, is unlocked. So all of this, as I say, is driven by the drive electronics as a pre-boot exercise before the operating system is loaded. Problem solved. That is, the problem of how to deal with the loss of control over stored data or data in general is solved by using self-encrypting drives. I mean, what better place to do encrypting stored data than in the drive itself, in the storage system itself? So I have stored data protection. If the equipment is lost, I have confidence the data is not exposed because the data is encrypted. All the user data that was ever written to the drive is encrypted. The encryption function can never be turned off by the user, as it can with software encryption. It comes to the factory, from the factory encrypting, and stays that way. A very important function that's recently been standardized by NIST is called crypto erase, where I simply ask the drive to replace and erase, to generate a new encrypting key and replace the old key. I've instantly sanitized the drive, and yet the drive is still usable. I can use it with that new encryption key as a new drive. I simply reformat it, I'm off and running. I didn't destroy the drive, my drive inventory, when I sanitized the drive. And this is now part of the Guidelines for Media Sanitation Special Publication 800-88, revision 1 of that standard. Now, of course, what's not addressed, I'm addressing here the protection of stored data. What's not addressed is the protection of data in flight, but of course you use TLS or some other functions in communications to protect transitory data in flight. And the drives are locked until I present the authentication key. So once I present the authentication key, the drive is unlocked for use, for normal use. Let me just itemize some of the benefits, or summarize the benefits of self-encryption. First, performance. Each of the self-encrypting drives is encrypting all the data transferred to it transparently. Your users, in fact, need not know that the encryption is actually going on, because the only place the encryption exists is on the drive media itself. And it's very fast. There's no interference with the prime directive of the drive, which is to store data. Now, each drive has its own little encrypting engine operating at full drive speed. So if I add 100 laptops to my business, or if I add new RAID systems to my data center and new drives to the data center, each of those self-encrypting drives has its own encrypting engine, and therefore the performance scales linearly. I have 1,000 drives. I have 1,000 independently operating encrypting engines, and so the performance scales very linearly. There's no need for re-encryption when I change the change the authentication keys. I can change these external authentication keys that I manage on a daily basis, a weekly, whatever your key management schedule would be for that key that's used to unlock the drive. But changing the authentication key does not change the encryption key, therefore no need for re-encryption. In security, there's no need, there are no back doors to this system. The standard is there. The Trusted Computing Group standard is built, is defined and published, and the drive industry is building to that standard. There's no access without authentication. I mentioned that it takes the authentication key by an authorized person to unlock the drive. And again, all user data is encrypted. It's always encrypted coming from the factory. Can't be turned off by the user. And most importantly is this crypto erase function that is been standardized now by NIST and is a very useful way. And as Tom indicated, it's in fact one of the only reliable ways to erase a a solid state drive is with crypto erase. Manageability. The important thing here is that the Trusted Computing Group standard provides a management interface standardized across the industry, so that all drives from competitors and others provide and present the same management interface. So these are managed drives, self-encrypting drives. The encryption happens in the drive at a very low architectural level, if you will, so there's no interference with any of these higher layer functions like RAID systems, the RAID function, backup and restoring drives, compression of data, deduplication of data, or data loss prevention. All of these functions here are above and beyond the encryption function that's going on inside the drive. And a much lower cost of disposal, certainly using crypto erase. With that, I want to turn this over to Hussein, who is going to describe for us the deployment, a real-life deployment of self-encrypting drives. Hussein?
Hi, good afternoon. Thank you, Dr. Willett. Thank you for having me on the webinar. I'm here at St. Barnabas, Barnabas Health, working as the System Director for IT Security. We are a largest healthcare network out in New Jersey. We operate 6 hospitals and the ambulatory care center and number of medical practices and number of specialty care practices within our healthcare system. We treat about 2 million patients a year. We have about 19,000 employees, 4,600 physicians that perform myriad of clinical care in our healthcare system. Our environment is predominantly desktop, so we do have about 2,400 laptops deployed to physicians, healthcare professionals, biomedical equipment executives who deal with patient health information, intellectual property, research data, and whatnot. So it's prudent for us to protect all the data that's stored on mobile devices. In fact, we have actually standardized on SED drives on our desktops moving this year so that we can protect the data on desktops as well. A little bit about our environment. Like I mentioned, we are an integrated delivery network. We have about 13,000 desktops, which we will be encrypting in the following 4 years. 400 will probably be encrypted this year using the SED drives. The key benefits of SED drives that we have realized after deploying an agent-based solution was the performance, the quick turnaround, and easy deployment cycles that we had to deal with the SED drives as opposed to the agent-based drives. Our need for data encryption arises from, as I mentioned, from regulatory requirements of HIPAA to protect the patient data, the safe harbor exemption that comes with it. If we can demonstrate that we had successfully encrypted and maintained the encryption password and keys securely and the data is not at a risk of exposure. We do have a lot of intellectual property because we run 2 teaching hospitals that have a lot of research done. We do a lot of specialty transplant services. A lot of that data is even more required to be secure than PHI. So the key here is to build a business case to the management for the need of encryption on mobile devices or any data at rest source. So you need to go out and simply do a marketplace analysis, see what's out there, what are the pros and cons of utilizing a SED drive versus a agent-based drive, and put together some business case for it. It really doesn't have to be a FUD factor, but it really has to do the risk assessment, risk mitigation techniques there to ensure that the data is protected. The way we looked at deploying the SED drives were, since we had agent-based encryption on our laptops, we decided to bake the SED drives into our laptop lifecycle plan. So as the laptops came off lease, we brought the new ones in with SED drives so that they could be rolled out. And we knew that the deployment cycle would be no more than not deploying any SED drives because the encryption, like Dr. Willett said, it's right on the board. So it's really not impacting any encryption cycle or deploying the laptops sitting in a depot to be encrypted and requiring the users to come in and put their password in so that the drives can be locked using their credentials. We did select a platform to collect all the keys so that the keys are in a database or the passwords are in a database, and also have a recovery password generated on that laptop so that if the user was not able to get back into the laptop, we would be able to recover the data for them, and if there was any reason to recover the data due to the unavailability of the user, we would still be able to do that. We did have to train our support desk, our help desk, our technicians to be able to handle the laptops differently with the SED drives in them so that we were able to reset the drives when we needed to. We did communicate it to our user community to make sure they understand that the drives are going to be encrypted and it's added protection, and they will have to unlock the drive when the boot as a pre-boot process, and that password is also collected into the management work system so that we could recover the data if we needed to. You can go forward and actually integrate that into AD if you have the right management solution. The solution we use is from Wave. We integrated with AD, and we also store the passwords in a database for recovery purposes and also for demonstrating that we have a secure locked drive if there's a loss of its asset. It plays into the governance that we have. We have to publish a report monthly showing all our mobile assets are encrypted, and that's the management system we use to kind of do that. We publish a report, and then if the drive has not been checked in, we can figure out who hasn't checked into our system. That's pretty much in a nutshell. It is how we have rolled out the SED drives to protect the data. Back to you, Brian.
Thank you, Hussein. We'll do a couple of conclusions here. So the future of self-encrypting drives really is to encrypt everywhere, whether it's the data center, the platform at the office, the mobile device, or the USB drive. It is standards-based. We have multiple vendors providing solutions, so that does provide interoperability across the platforms by using those standards. And we have unified key management systems that are developed by the TCG membership and the ISV community to provide all forms of authentication key management for the storage, and simplified key management because the encryption key never leaves the drive. So there's no real need to do classic key management of keys in a database. They're all protected persistently in the hardware. And it's transparent. It works across different operating systems, applications, databases, and it provides a very clean administrator capability for IT to control and manage their user base and recovery of passwords, as well as the maintenance of their platforms. As well as the automatic performance and scaling, we really look at this as data is protected in encryption and hardware, as Michael talked about, Dr. Willett, and that really alleviates the need to do that granular classification of data. A couple of key strategies to remember, some leave-behinds for you all. Our recommendation is to purchase all new machines that you're buying, laptops or enterprise data storage with self-encrypting drives, whether they're rotating media or solid state. Retrofit any high-risk legacy machines right now. There is a retrofit channel of products available for self-encrypting drives. Restrict access to stored sensitive data on machines with self-encrypting drives in the early rollout. And when you're starting to look at the data center, use self-encrypting drives so that you can have balanced encrypted storage at all times. Phase in the SEDs into your data center as quickly as you possibly can because it runs at drive speeds. You don't have that overhead associated with typical encryption schemas. And avoid and minimize your need for data classification in the future. And be really aware to accommodate other data security contexts that you have in your organization. And with that, we are going to move to some questions. We've had quite a few posted to us today, and so I'll hand those off to several of our panelists today. A couple of quick housekeeping items. The slides will be available for download later. They'll be on the TCG website on the event page under the Data Protection tab. So if you go there later today, you can download these slides. And the ability for you to use those, you can download those from the TCG site for that. The webinar will also be available for replay, both posted on the TCG site and here at Bright Talk. So some questions. We'll start with Tom, since you went first today.
All righty.
Here you go. What is your long-range view of using SEDs in the enterprise?
Well, I think there's a definite value of using SEDs in the enterprise. The enterprise market often consists of high-performance hard disk drives, or high performance, high use hard disk drives or SEDs in single server applications, or arrays of these devices. And the data that is stored either on the servers or on these arrays could fall into the wrong hands if it's not encrypted. So I think that ultimately it's going to be one of the big use areas is going to be in the enterprise space. Although it's not the initial market that's picked up on this, that it is going to be end up being a significant part of that market, if not, and eventually all of it, will use self-encrypting drives in the near future.
Great, thank you. Quick question for you, Michael. What happens with SEDs when the drive fails and requires recovery? Backups are not always implemented, even though they should be. Is there a way to recover the lost data from a self-encrypting drive?
The short answer there is no. I mean, the purpose of encryption is to protect data, and except to those that are authorized to view it and have the authorized credentials. So no, in that sense. But as the questioners indicated, the answer to that is the SED encryption function is only protecting the data on that particular drive. If you have sensitive data in your enterprise, you should be backing it up, especially if it's mobile. So there's a requirement, a co-requirement of having a backup strategy, as there is in any security context, of backing up your data so that if it's lost on one particular media, I still have it backed up on another. But no, the SED function, by its very definition, is meant to keep anyone not authorized from seeing the data.
Thank you, Michael. Okay, Hussein. In healthcare, if you lose or have lost a device, how did SED technology help you with reporting costs and securing the data?
So in healthcare, the incident response is one of the HIPAA requirements. And if a device with PHI data or PII data is lost, a proper risk assessment has to be performed. And if the risk assessment end result is that there's a potential breach of data, because we can never tell whether it's exposed or not. We can only surmise. And then we have to invoke the breach notification policy, which goes through which has its own cost. It has its own risk assessment and regulatory, legal, and breach management expenses have to be incurred, which can be as high as $150 a patient record. So with having an SED drive in a mobile device, such as a laptop, if it's misplaced or stolen, and we can demonstrate that the encryption password was strong password, and we can provide documentation to our legal department or our privacy department that, look, we can ascertain that or authenticate that this, or attest rather, that this device has an encryption password strong enough for somebody not to be able to break into it, we should be exempt from breach notification under the safe harbor. So that's the process we go through. We have had in a couple devices misplaced, which did have the strong password on it for the encryption, and we were able to produce the documentation out of our encryption management system, attach it to the risk assessment, and submit it for review and approval.
Thank you, Hussein. Tom, back to you. What do you believe is the future forecast and adoption curves for SEDs for the consumer?
Well, aside from the consumer laptop market, where I think there could be a clear case, a lot of consumer devices with hard disk drives in particular, but also with solid-state devices, there are like digital video recorders or mobile and other sort of playback devices, home media centers, things of that sort that have hard disk drives in them. They're oftentimes using somebody else's content. And it's not unique data, and it may not have, other than to the content owner, it may not have a value or especially a security value to the individual. So while I think there is going to be, as more drives become self-encryption capable, it's likely that will also include the consumer hard disk drives and SSDs. That again, aside from its use in the laptops or mobile devices where productivity work is done and original content is created, that I think that it will be one of these slower developing markets. At least the drivers for its growth in the use of encryption will be lower in those markets.
All right, thanks, Tom. And I'm just going to wrap it up with one final question from Michael, a little technical one. It's a little crystal ball question for you. And combining two questions that we have here. One is there intention for TCG storage specifications to extend to mobile phones or USB drives? And what is your prediction on other device types that the Opal spec will start to show up in?
Good one. I should mention the Trusted Computing Group has its own trusted mobile device work group that has itself developed a set of specifications. So I'd urge the readers, the listeners, to look at that trusted mobile phone specification work, because the mobile phone industry is beginning to respond to those specs as published by the mobile phone, the mobile group. Secondly, I mentioned that the work group, the storage work group, works through this concept of a subsystem class. So we've already defined 3 subsystem classes derived from the trusted storage spec, core spec, one for laptop, one for enterprise, and one for optical. So for other media like that are smart enough to embed a AES encryption algorithm in hardware and smart enough to be able to run a little bit of firmware, that would be sort of a prerequisite. What we're looking for is for that a group of interested developers from multiple industries to get together and develop a subsystem class for that. It may not be Opal. Opal may be very applicable to those environments, and yet there may be other restrictions that apply. And so it's the right way to do it would be for an interested group to get together under the guidance of the trusted TCG storage work group and develop a subsystem class for that class of devices.
Thank you, Michael. And finally, I would like to thank our panel presenters, Tom Coughlin of Coughlin Associates, Dr. Michael Willett from Samsung, and Hussein Syed from Barnabas Health. The webinar will be online.
Brian, there are some more questions in there.
We're wrapping up, Tom.
Okay. Okay.
The webinar will be available online shortly for future viewings. Please also vote and provide your valuable feedback on the session. Thank you for attending TCG's Data Security Using TCG Self-Encrypting Drive Technology webcast. And thank you again. Goodbye.